There is a powder that costs less than $1 and kills rust inside your engine permanently. Not temporarily. Not partially. Permanently. It flushes rust from coolant passages, dissolves mineral scale from water jackets, clears blocked heater core tubes, and restores flow to corroded radiator channels. All from a powder you can buy at any grocery store. The United States Navy used it to descale entire ship boiler systems during World War II. Industrial chemists have documented it since 1784. Breweries across Europe have flushed their steel fermentation tanks with it for over 200 years. Pharmaceutical factories use it today to clean stainless steel production equipment. The FDA has approved it as a food-grade additive. It is inside the candy you eat and the soft drinks you pour over ice on a summer afternoon. It chelates iron oxide at the molecular level. It wraps around each molecule of rust, breaks its bond with the metal surface, and suspends it in liquid so it flushes out completely. One treatment. No disassembly, no mechanic, no special equipment, a plastic bucket and warm water. Then someone in a boardroom calculated what would happen to the $75 billion engine cooling system repair industry if every car owner on the planet found out about a $1 powder that made coolant system failures nearly obsolete. They did not stop using it because it did not work. They stopped talking about it because it threatened every radiator shop, every coolant flush franchise, every dealership service bay, and every aftermarket water pump manufacturer on Earth. This is the story of a compound that navies, empires, and entire industries trusted, and one industry buried. Stay here, because by the end of this video you will know exactly how to use it yourself, and the automotive service industry will be very uncomfortable that you do. Now let me take you back to where this all begins. More than 3,000 years before the first combustion engine was ever assembled, beer brewers in ancient Egypt discovered something entirely by accident. They were fermenting grain in clay-lined copper and bronze vessels along the banks of the Nile. Over time, thick mineral crust and metallic residue built up inside those vessels, choking flow and contaminating batches. The brewers needed a way to clean the metal without damaging it. And they discovered that soaking the vessels in naturally sour fruit juices, particularly juices from tamarind pods and unripe citrus fruit, dissolved the mineral scale completely and left the metal underneath gleaming and smooth. They had no word for chelation. They had no concept of pH. But they understood that sour liquid dissolved what was stuck to metal. Every brewery workshop along the Nile used this technique. Every generation of Egyptian metalworkers passed it forward. And they were not alone. By the height of the Roman Empire, engineers managing lead and bronze pipe networks beneath marble cities had observed something remarkably similar. Aqueducts fed by water sources running through citrus groves and decomposing orchards carried slightly acidic water. Those pipe networks stayed cleaner and more free-flowing over decades than identical systems fed by alkaline mountain springs. Roman infrastructure maintenance records document the difference. Engineers at frontier outposts began deliberately introducing acidic rinses into pipe systems during seasonal maintenance. That is a 2,000-year-old plumbing manual describing the exact same chemistry you are about to learn today. By the 12th century, monks running monastery breweries across medieval Europe had refined the technique further. They used sour fruit mash, fermented citrus rinds, and concentrated fruit acids to scour copper kettles and iron-banded fermentation barrels between brewing seasons. The acid dissolved rust, mineral deposits, and biological residue without pitting the base metal. This knowledge passed through monastic brewing guilds for centuries. Every abbey with a brewery and an orchard knew the formula. Half a world away and 3 centuries earlier, Persian and Arab alchemists during the Islamic Golden Age had gone further than anyone. Chemists working in the tradition of Jabir ibn Hayyan isolated crystalline organic acids directly from citrus fruit in the 8th and 9th centuries. They documented in meticulous written records that these crystals, dissolved in warm water, completely removed iron rust and copper verdigris from metal tools and laboratory equipment. This was among the first recorded chemical isolation of the compound in human history. They wrote it down. They tested it. They published the results in manuscripts that still survive. Across Asia, Chinese and Indian artisans used acidic fruit solutions to clean iron dye vats and metal silk reeling equipment for centuries. The knowledge traveled along the Silk Road, carried by traders who understood that sour fruit kept their iron tools clean in humid monsoon conditions. In South America, indigenous metalworkers used fermented citrus and tamarind preparations to remove corrosion from traded iron implements long before industrial chemistry arrived on the continent. Every civilization that worked with metal and had access to citrus fruit, tamarind, or fermented grain arrived at the same conclusion independently. Sour dissolved rust. That is not folklore. That is not an old wives' tale from a survival blog. That is convergent chemistry, observed and applied across 5 continents and 3,000 years of recorded human history. Fast forward to 1784 in a laboratory in Sweden, a chemist named Carl Wilhelm Scheele did something no one had done before. He isolated the pure crystalline compound from lemon juice for the first time in recorded scientific history. He documented its molecular behavior, its reaction with iron oxide, and its remarkable ability to chelate metal ions, meaning it wraps around each metal oxide molecule like a chemical claw, grips it, breaks its bond with the base metal, and holds it suspended in solution. For the first time, laboratory science could explain what brewers, monks, alchemists, and tanners had observed for millennia. The compound does not simply attack rust the way an abrasive does. It does not scrape or sand or grind. It kidnaps rust. Every single molecule of iron oxide gets surrounded, detached from the metal surface, and carried away like a prisoner extracted from a building. The metal underneath is left untouched, undamaged, and completely clean. And that distinction matters enormously for what happens inside an engine. Rust forms in coolant passages, water jackets, heater core tubes, and radiator channels. These are internal surfaces you cannot reach with sandpaper, wire brushes, or any physical tool ever manufactured. The only way to remove rust from the inside of an engine cooling system is chemically, dissolved in the fluid that flows through those passages. The compound Scheele isolated does exactly that. It circulates with the fluid, contacts every internal surface, chelates every molecule of rust it touches, and carries it out when you drain the system. By the mid-1800s, industrial engineers across Europe and America had figured this out. And what they did with it next made the modern automotive service industry very nervous. In 1939, the world went to war, and engine corrosion became a military crisis on an industrial scale. Liberty ships and destroyers running steam boiler systems in the United States Navy suffered catastrophic mineral scale buildup in seawater-cooled systems. Scale deposits choked heat transfer surfaces, caused overheating failures, and crippled propulsion systems at the worst possible moment. Navy maintenance depots needed a solution that was fast, effective, cheap, and safe enough for minimally trained sailors to handle in shipboard conditions. They found it in a powder that cost pennies per treatment. Bureau of Ships maintenance protocols, declassified after the war, document the systematic use of the compound dissolved in hot water to flush and descale boiler tubes, condensers, and heat exchangers across the Pacific and Atlantic fleets. Thousands of tons were ordered. Entire shipyard maintenance operations were built around the procedure. Destroyers, cruisers, aircraft carriers, and submarine tenders all received the same treatment from the same $1 powder mixed in the same steel drums by the same Navy machinists, standing in the same engine rooms. After the war ended, the knowledge did not disappear from industrial use. It simply moved behind factory walls where consumers never saw it. Power plants adopted the compound as standard procedure for descaling heat exchangers and boiler systems throughout the 1950s and 1960s. Paper mills, steel mills, and oil refineries worldwide integrated it into routine cooling system maintenance. Dairy processing plants, pharmaceutical manufacturers, and food production facilities use it today, right now, this year, to descale stainless steel equipment. It is FDA approved. It is used in food processing. It is one of the most thoroughly tested, safest, and most effective rust and scale removal agents ever documented by modern chemistry. A 50-pound industrial drum costs roughly $40, enough to descale an entire factory floor of heat exchangers, boilers, and cooling systems. The amount you need for one car engine costs less than $1. The Society of Automotive Engineers and ASTM International have published testing data on cooling system descaling agents for decades. The compound consistently outperforms commercial coolant flush products at a fraction of the cost. The data is not hidden. It is published in engineering journals sitting on library shelves. It is taught in university chemistry courses. It is printed in FDA food additive databases available to the public. So if the United States Navy trusted it with warship propulsion systems, if power plants trust it with million-dollar turbine cooling circuits, if the FDA approved it for human consumption, if pharmaceutical factories use it to clean equipment that produces the medicine you swallow, then why has no one at your local dealership ever mentioned it to you? Let me answer that with simple math that will make you very uncomfortable. The automotive cooling system repair market in the United States alone generates billions of dollars in annual revenue. Think about every component involved. The average radiator replacement costs $400 to $900. The average heater core replacement costs $600 to $1,500, and that cost is driven almost entirely by labor because the heater core is buried behind the dashboard and requires hours of disassembly to reach. The average water pump replacement costs $300 to $700. The average thermostat replacement costs $200 to $400. A routine coolant flush service at a dealership costs $150 to $250 and takes a technician roughly 30 minutes. Now multiply those numbers by the roughly 280 million registered vehicles on American roads. Scale that globally to over 1 billion passenger vehicles. The numbers become staggering very quickly. The entire cooling system service industry is built on one foundational assumption. That mineral scale and rust buildup inside your engine is an inevitable, recurring problem that requires periodic professional intervention. Every coolant flush interval printed in your owner's manual. Every recommended service notification that pops up on your dashboard display. Every dealership service advisor who leans across the counter and tells you that your coolant is past due, all of it assumes you will keep coming back every 18 months, every 30,000 miles, for the entire life of the vehicle. A $1 powder that any car owner can dissolve in warm water and pour into their own radiator, run the engine for 30 minutes, drain and flush, eliminating years of accumulated rust and scale deposits in a single afternoon in their own driveway, is not a product opportunity for the automotive service industry. It is an extinction-level event for their revenue model. A permanent solution is not what the service industry wants. A permanent solution is what the service industry has worked for decades to make sure you never find. And just like every other suppressed solution, they did not make it disappear. They repackaged it, marked it up, and made sure nobody recognized the original. Walk into any auto parts store right now and look at the shelf of commercial coolant flush products. Pick up any major brand. Turn the bottle around. Pull up the safety data sheet on your phone. The primary active descaling agent in the majority of those products is the same compound. The same molecule, the same chemistry Scheele isolated in 1784. The same powder the Navy dissolved in steel drums in 1943. They take $1 worth of naturally occurring food-grade powder, dissolve it in water with some surfactants and dyes and corrosion inhibitors, pour it into a branded bottle with a race car on the label and aggressive marketing copy, and sell it back to you at 15 to 40 times the actual cost of the active ingredient. $1 of powder in a branded plastic bottle becomes a $15 to $25 professional-grade cooling system treatment. The only thing professional about it is the profit margin. The nomenclature trick makes the disguise even easier. On commercial product labels, the active ingredient does not appear under its simple, recognizable grocery store name. Instead, it becomes proprietary chelation compound, or stabilized organic descaling agent, or advanced mineral dissolution formula, or patented oxide removal technology. Same molecule, new vocabulary, dramatically higher price point. Dealership service departments push the concealment even further. Dealer-applied cooling system protection packages costing $200 to $500 spray compounds that contain the same ingredient blended with glycol and corrosion inhibitors through a machine that cost the dealership $3,000. The machine exists primarily to justify the labor charge. The powder does the actual work. The machine gives it a premium factory-applied appearance. And the price tag convinces you that you are receiving space-age technology performed by highly trained specialists. You have been paying luxury prices for a grocery store powder dissolved in warm water, and nobody who profits from your engine rusting from the inside has any financial motivation to tell you the truth. And nobody has been hit harder by this suppression than everyday car owners, backyard mechanics, and anyone who has ever stared at a four-figure repair estimate for a cooling system problem. Think about every vehicle you have ever owned. Every time the temperature gauge crept toward the red zone on a hot summer afternoon because scale-clogged passages could not transfer heat fast enough to keep the engine cool. Every time the heater blew lukewarm air in January while you sat shivering in traffic because the heater core was half blocked with rust sediment that reduced flow to a trickle. Every time you drained the coolant during a routine service and watched brown, orange, or black sludge pour out of the petcock and wondered what that contamination had been doing to the inside of your engine for the last 60,000 miles. Think about every project car you have ever pulled out of a field or a barn with a cooling system full of orange mud. Every classic truck with a radiator so scaled up that it could not survive a 20-minute highway run without the temperature gauge climbing into the danger zone. Every engine block you considered replacing because the water jackets looked too far gone to salvage. Think about every truck owner running hard on desert trails or towing a loaded trailer uphill in August with coolant temperatures climbing because the cooling system is operating at 60% efficiency. Not because the radiator is too small, not because the water pump is failing, because nobody ever told you that the internal passages were clogged with rust and mineral scale that you could have removed in a single afternoon for less than the price of a cup of coffee. The solution has been sitting on the grocery store shelf the entire time, next to the baking supplies, next to the canning jars, waiting for someone to remember what the Navy, the breweries, the power plants, and the pharmaceutical factories never forgot. Here is exactly what to do, and it is almost insultingly simple. Go to any grocery store, pharmacy, bulk food supplier, or online retailer and purchase food-grade citric acid powder. That is the product. That is the compound that empires trusted and the automotive industry buried. Citric acid, a 100-gram bag costs between $1 and $3 depending on the source. You need approximately 50 grams, roughly 3 level tablespoons, for an average passenger car cooling system. Step 1. Start with a cool engine. Open the radiator drain petcock or disconnect the lower radiator hose and drain the existing coolant from the system into a clean container. If the coolant is still within its service life, save it for reuse. If it is old or contaminated, dispose of it properly according to your local regulations. Close the drain petcock once the system is empty. Step 2. Dissolve 50 grams of citric acid powder in approximately 1 gallon of warm distilled water. Stir until fully dissolved. The solution will be clear and have a faint tart smell like diluted lemon juice, because that is effectively what it is. Step 3. Pour the citric acid solution into the radiator or coolant reservoir. Top off the system with additional distilled water until it is completely full and there are no air pockets at the filler neck. Step 4. Start the engine and immediately set the cabin heater to maximum heat. This is critical. Setting the heater to maximum opens the heater core valve and ensures that the citric acid solution circulates through every passage in the entire cooling system, including the heater core, which is the most common location for flow-restricting rust and scale buildup. Let the engine idle until it reaches full operating temperature. You may hear improved coolant flow through the heater core as deposits begin to dissolve and passages clear. Run the engine at idle for 30 to 45 minutes. Do not drive the vehicle during this process. Let it idle in your driveway. Step 5. Shut off the engine. Let it cool until it is safe to handle. This takes approximately 60 to 90 minutes depending on ambient temperature. Do not open the cooling system while it is hot. Open the drain petcock and drain the citric acid solution into a container. Observe the color. It will be dark orange, brown, greenish black, or some combination depending on the amount of rust and mineral scale that was lining the inside of your engine. That color is dissolved corrosion that was choking your cooling system for years. It is now suspended in the solution and leaving your engine forever. Step 6. Fill the system with clean distilled water. Run the engine for 10 minutes at idle with the heater on maximum. Shut it off and let it cool. Drain the rinse water. Repeat this flush cycle 1 or 2 more times until the water drains clear. For heavily contaminated systems, you may want to do a second citric acid treatment before the final rinse cycles. Step 7. Once the rinse water runs clean, fill the system with your preferred coolant mixture. Most vehicles call for a 50-50 blend of coolant concentrate and distilled water. Consult your owner's manual for the correct specification. Bleed any trapped air from the system following the procedure in your vehicle's service manual. Some vehicles have a bleed valve on the thermostat housing. Others require running the engine with the radiator cap off until all air bubbles stop. Follow whatever procedure your specific vehicle requires. For severely clogged heater cores, disconnect the 2 heater hoses at the firewall, connect a garden hose adapter to one side, and flush the citric acid solution directly through the heater core in both directions. Let the solution sit inside the heater core for 30 minutes, then flush with clean water. This direct flush technique has restored heater cores that were producing zero heat output and would otherwise have been replaced at a cost of $800 to $1,500 in shop labor. For radiators removed from the vehicle during a rebuild or restoration, fill the radiator with a stronger citric acid solution, let it soak for 2 to 4 hours, then flush thoroughly with clean water before reinstalling. For engine blocks during a rebuild, fill the water jackets with citric acid solution and let it soak overnight before final cleaning and assembly. Here is the cost math. 50 grams of citric acid powder costs approximately $1. 1 gallon of distilled water costs approximately $1.50. 1 afternoon of your time, most of which is spent waiting while the engine idles and the chemistry does the work. Total investment, under $3 and roughly an hour of active effort. Compare that to a $150 to $250 dealership coolant flush that uses a diluted version of the same compound, pumped through a machine that exists primarily to justify the labor charge. Compare it to a $900 radiator replacement for a unit that was not physically damaged, but simply clogged with scale deposits that citric acid would have dissolved in 30 minutes. Compare it to a $1,400 heater core replacement that required 6 hours of dashboard disassembly because nobody told you that a $1 powder flushed through a garden hose adapter could have restored full flow in your driveway. A mechanic working on trucks in the rural Midwest began documenting his citric acid cooling system treatments in 2019 on a 2003 pickup with 190,000 miles and chronic overheating. The dealership had quoted $1,400 for a radiator and heater core replacement. He drained the cooling system, dissolved 50 grams of citric acid in warm water, poured it into the radiator, ran the engine for 40 minutes at idle with the heater on full blast, and drained fluid that looked like dark coffee. After the treatment, the engine operating temperature dropped 15 degrees from where it had been running. The heater went from lukewarm output to full, face-melting hot air within minutes of startup. The overheating problem disappeared completely. 18 months later, after a full summer of towing and a winter of heavy use, the truck showed zero recurrence. Zero overheating. Zero heater core restriction. Total cost of the fix, $2.60. The dealership quote was $1,400. The actual repair cost $2.60. Let that contrast sit with you for a moment. Then ask yourself why the dealership never mentioned the $2 option. The chemistry does not wear off because it does not leave a coating behind. It removes the problem entirely. The rust is gone. The scale is gone. The passages are clean. Refill with proper coolant containing the correct corrosion inhibitors for your vehicle, and the system is restored to factory new flow capacity. There is nothing left to flake off, nothing left to reclog, nothing left to choke the system from the inside. Every civilization that worked with metal and acid understood this fundamental truth. Egyptian brewers cleaning bronze vessels on the banks of the Nile 3,000 years ago. Roman engineers flushing pipe networks beneath marble cities across an empire. Medieval monks scrubbing copper kettles in candlelit monastery cellars after the autumn harvest. Persian alchemists crystallizing acids from citrus fruit under oil lamps during the golden age of Islamic science. Navy machinists descaling destroyer boilers in shipyards while the world burned around them. Power plant engineers flushing turbine cooling circuits in concrete buildings where the hum of generators never stops. $75 billion in cooling system repairs depends on you never learning what any of them knew. $250 dealership coolant flushes depend on you never reading the ingredients on the back of the commercial bottle. $1,400 heater core quotes depend on you believing that internal engine rust is an unsolvable problem requiring professional intervention and professional pricing. But chemistry does not care about service intervals. Chelation does not expire. And citrus fruit has never charged a labor rate. If this changed how you think about the rust forming inside your engine right now, share this video with someone who is about to spend $500 on a cooling system repair that costs $1 to prevent. Every single share puts a crack in the wall they spent billions building around knowledge that was never theirs to lock away. Subscribe, because this channel is going deeper into the vaults they thought were sealed forever. The next vault opens soon. And what is inside is the one compound every dealership charges $800 to apply to your paint that you can make at home for less than $5 with 2 ingredients from a hardware store.